So what are we talking about next? Now we're going to be moving over and talking about Microsoft and VMware. So differentiating the products,
and,
right?
And as I said in the beginning, this is not about putting one beside the other and starting to point out individual features where maybe one falls short of the other or vice versa. There's a couple of schools of thought on that. Number one, there's lots and lots of independent studies that have been done.
Yep.
If you want to do performance comparison, don't take our word for it. Number one, look at the studies. Number two, if you're going to do things like performance comparison or feature comparison, set it up in the environment that you're gonna need to run it in, and try it and see.
You sample production workloads, right?
Exactly. I mean, and the reality is that certainly we're biased to Microsoft. I'm biased to Microsoft, even though I do a lot of other things as well. And I would certainly hope that in those scenarios the Hyper-V implementation would win. But the reality is it won't always win, and that's fine. If it doesn't meet the business need, it doesn't meet the business need. But certainly you need to try it, you need to do it, you need to put it in something that is real and legitimate and map it to your actual business needs, not what you might read on the web or what might be written in an RFP, what you would legitimately need, and see how it stacks up.
All right, well, let's jump into it and talk a little more about Microsoft, VMware, and the terminology and understanding.
So this is the alphabet soup, and for you guys that are very ingrained in VMware and use VMware a lot, and are wondering what are the comparable things in the Microsoft stack, so you can actually begin doing the research and understanding the language, this will help you out quite a bit.
Absolutely. So let's talk about terminology. Now, once again, our goal here isn't to say that one's better than the other. We have a bias towards Microsoft. We'll admit that up front. But we really just want to give you the tools to understand, throughout the rest of the course, what are we referring to? What are the Microsoft technologies, and what are the equivalent VMware technologies? Now, I think the first one to talk about is the self-service portal. Now, the self-service portal, this gives us the ability really best in the private cloud scenario, but to kind of give your end users some ability, some power to go and make change requests, right? I need a new virtual machine, or I need a new server, right? We're going to put it in a virtual machine. How many gigs of RAM do we need? How fast does it need to be? How much storage do we need? And that's going to be equivalent to VMware's web access. Absolutely.
In terms of management tools, the base management tools, the Hyper-V Manager, the MMC snap-in, that's where you would go to make a VM, start a VM, stop a VM. Single server environment, it supports multi-server, but you would add multiple servers. There's no consolidated view. For that, we have Virtual Machine Manager. Remember the System Center suite, full System Center product. We've just released, I say we, you, not that I haven't, just released VMware 2012, the beta. So that's certainly the big tool you have. And one of the big questions we get is, do I need VMM? And the answer is yes and no. I deal a lot with small business, and I should say mid-business, like 1,000 seats or less. I deal a lot with that. And for those kind of implementations, a lot of times what we wind up doing is building, like a 2 or 3 node Hyper-V cluster. And for something like that, you probably don't. If you're not taking advantage of things like templates, libraries, automated deployment, self-service provisioning, then it's a product you've got to install, maintain, and learn how to use. You might not need it, right? You may be able to get away with it's a little more kludgy to manage with just the MMC consoles, but you trade complexity for simplicity in that case.
Exactly. And that's equivalent to vCenter. So VMM equivalent to vCenter.
Exactly.
And the Hyper-V Manager, which is the core in-the-box product, that's equivalent to the vCenter.
Exactly. The Protection Manager is the consolidated backup. That's the backup suite that we'll be showing you a little bit later on. And then we have something called Performance and Resource Optimization. Also throw another term in there called Dynamic Optimization, which is a VMM 2012 term. And those sort of tools combined are very similar in concept to the Distributed Resource Scheduler.
Now, let's talk more about virtual machine terminology, right? This is a course about Microsoft virtualization for VMware virtualization guys, so it's going to be an important one.
Absolutely.
Now, for us, the integration component. This is essentially the agents that you go and stick in the VM guest itself that allow us to be what we call enlightened and allow the guest to go and communicate with the host and understand that kind of communication channel. So it knows it's a VM and it can be effectively managed as a VM.
Absolutely.
And that's similar to the VMware tools that you go and install in your VMware.
The parent partition is the service console. The parent partition is the core partition of the hypervisor stack. It's an architectural term. But if you translate this into something you can kind of touch, it's the installation of Windows on the machine that Hyper-V is running under, would be the parent partition. So it's the one Windows that you have before you ever VM. You have VM IDE boot and VM SCSI, which are comparable terms. Hot-add disk storage and memory. Hot-add disk storage and memory.
Pretty straightforward, but how do we use that? Why is that interesting for the admins?
In a couple of different ways. Hot-add memory is part of the dynamic memory tool set, and then hot-add storage allows you to, in certain scenarios, do things like add VHDs to running VMs. So you can increase the storage of an Exchange server or a SQL server if you need to without needing to incur downtime on that box.
And VHD, that's a good terminology as well to compare. What's our VHD equal to?
VMDK.
Exactly, and that's basically our disk format, our disk structure for our virtualized hard disks, hard drives.
VHD, though, is within the Microsoft realm, is used a lot more than just within Hyper-V. It's a spec that's been used starting with Virtual Server, Virtual PC. It's been readily adopted by Citrix for a lot of their Zen desktop implementations, and you can even boot from it, which is actually one of my favorite things to do.
Really cool, yeah. Just go install the VHD, boot straight to the VHD.
And when you talk about Hyper-V bare metal deployment, that's the technology it's using. It takes a VHD, uses a PXE boot technology, drops the VHD on the bare metal machine, and then boots the VHD, no hypervisor. So it's a file format similar to a WIM file, similar to a zip file conceptually. It's a container file for a file system.
Very cool. And core parking, this is really one of the big green IT initiatives, right? So, you're in the middle of the night, half of your servers aren't being used, maybe it's the weekend, so why have them up and running? Now, with Core Parquet, we essentially can put the cores in the deep sea state, and you can just, kind of put some of your servers to sleep so they don't use as much power. It's going to save time in your data center. And all of that can be done dynamically. You can schedule it, you could do it based on the performance of the servers right now, and so it really just gives you some management flexibility of saying, hey, I'm not using these servers, why have them up and running? And when I need them back, I can instantly, go turn them on, bring them back up, utilize them as I need to.
It's actually fun to do. You can actually track this in perfmon. So if you take a machine within Performance Monitor, you can add the individual CPUs to perfmon, and you can actually track the utilization. And there's a counter that measures percentage of C time, I think is the name of the counter. And so if you add not the collective processor utilization, but you add the individual cores, you can actually track which ones are in C states and which ones are not.
Very cool.
Now, the other interesting thing here is that most modern servers support C states in the CPU. Most CPUs do. Not all of them ship with it turned on in the BIOS. So if you're looking at this feature and you're sitting there thinking, Corey said I could open perfmon and I could make the machine idle, and I'd have one core that was spiked and the rest that were low. Make sure it's turned on in the BIOS because it's not always turned on by default. That I learned the hard way after troubleshooting for hours. So
now the virtual switch. So essentially, this is our switch that we use between the VMs. It connects the VMs to our outside switches. It's just basically a virtualized switch that we can use for any type of networking, whether that's creating a guest cluster by connecting VMs, hooking it up to external switches. Basically, it's our virtualized networking infrastructure. And that's going to be equivalent to either the standard or the distributed switch that VMware uses right now.
We have templates, which are templates.
Pretty straightforward, yep. Now, when do we use templates? Why are those interesting?
When you're doing automated deployment of VMs, it's a System Center Virtual Machine Manager term. And so within the VMM library, you have these template objects that represent collections of operating system settings and hardware settings. And we'll do more about this when we talk about System Center. But you use them as objects from the library to say, hey, I want 4 new VMs. Here's the template the VM is based on, go. And it'll actually deploy and install the operating system.
Very cool. Now, I guess the next big thing, or one of the big things that we've seen over the past couple of years is migration from the physical environments to the virtualized environments.
Yep.
And so System Center has some really nice tools, P2V, V2V, and basically they will convert the physical infrastructure into an encased VM, a VHD, and allow you to then go and use that VM without having to really redeploy and figure everything from scratch.
Notes from the field, okay, having done this a bunch. If you have one server to P2V, don't use this method to do it because it's a phenomenal tool and it works good, but it's like most automated things. There's a phase of troubleshooting, of development, of testing before you work the kinks out. I mean, you're taking an OS on a hardware platform and moving it to a completely different hardware platform. That it doesn't matter. That almost never goes smoothly the first time you do it. So if you've got a lot of hosts to P2V, take the time to make this smooth and use the wizard. If you've got one host, at the end of the day, it's quicker to just
might as well just go.
Just restore it from a backup. Make a backup, restore it from a backup. One good thing about this is it will actually do it online. So you don't need to take the host offline to do it.
Very cool.
Which is a neat feature. You also got to take into consideration, if you're doing a P2V on something that's live and changing, you may want to do the P2V, take a backup of the database, then restore of the database. It's not a magic button. P2V, any kind of migration of physical to virtual, never is just a magic switch that you flick on and
there's going to be some legwork to do.
Exactly. And don't let anyone tell you different, because unless you've done it a bunch, from someone that has, it's one of those things.
And finally, VMST, Virtual Machine Servicing Tool. So it's an out-of-band product released by the Solutions Accelerator team at Microsoft. And essentially, it just really helps enhance all of your servicing of virtual machines. Doing updates to them, patching them. Just keeping them maintained.
There's lots of folks that have gotten into trouble because they've had virtual hard disk files, be it VMDK files, be it VHD files, sitting in a library somewhere just idle for a year.
People forget to patch them,
and they're not patched. They bring it up, and something bad happens.
Something bad happens.
This can be rolled into your automated patching process so that it'll take care of that. Some of this functionality has been rolled into VMM 2012. There's some really neat cluster orchestration in there we'll talk about.
Yep.
That will actually move VMs around nodes, patch the nodes, move them back again. They've orchestrated that really, really well and put some really neat compliance checking in there. So we'll talk about that, but when we get there.
Very cool. Now, storage. I'm going to pass this one over to you. I think for the most part, you're Mr. Hardware guy. So VHD, I think we touched on that already. That's equal to the VMDK.
A pass-through disk on a raw device mapping is when you have a disk that is a physical disk. Now, when I say physical disk, it could be a LUN on a SAN. It can be a drive that's plugged into the machine via eSATA, for example. And you just pass it directly through to the OS, where the OS is storing the data natively as opposed to in a storage format like a VHD or VMDK.
So what are the benefits? It makes it much more efficient, right? Since
exactly.
You're going directly to the disk, you're passing it through, and you're not actually going through the OS as well,
exactly.
Right?
And also worth mentioning too, as we're doing this, folks, we're not saying at any point in time that a VHD and a VMDK are identical. We're doing this at a conceptual level, right? So the individual implementations are going to be a little bit different. VMware's is going to be a little tiny bit different. Microsoft's going to be a little tiny bit different. They're each going to have some individual features that the other does not or are done differently. So just bear that in mind. Quick storage migration, again, it's a VMM piece of technology. And what it allows you to do is move a VM from one host from one LUN or one storage location to another within a host without having to do a massive file copy of the VHD. It does some things behind the scenes to quickly migrate the VHD over in any of the time. A dynamic disk is a disk which will grow on demand. Okay, and we'll talk more about that when we get into the Hyper-V section a little bit later on. Similar in concept to VMware's thin provisioning of disks.
Okay.
And expand disk volume is making a VHD bigger, making a VMDK bigger. Similar concept, similar principle.
Now, let me stop you for a second. It looks like we have a few questions that are related to the whole networking piece. Now, let me just bring that up again. So first question for you, Corey. With Direct.io, can I connect a VM directly to a physical NIC?
Can you connect a VM directly to a physical NIC? You can connect it directly to the switch that's connected to the NIC. The switch is always going to kind of be in the middle there, but you can certainly have a one-to-one relationship. One thing I will mention, I noticed it on a question earlier, folks were saying, hey, is there a Twitter hashtag for this thing? And someone suggested MS Jumpstart.
MS Jumpstart.
MS Jumpstart. Right. So I thought I'd throw that out there. That I think is the unofficial claim Twitter hashtag for this sort of stuff. So.
All right. Another question for you. Can a dynamic disk be a basic disk that is also expandable, or is it just a dynamic disk?
I want to make sure I understand the question.
So basically, when you go and pre-configure this initially, must I initially say this is a dynamic disk, or can I start as a basic disk and let it gradually grow over time?
Okay, so let's not confuse terms a little. The VHD format will be either dynamic or fixed size. Okay, there's also referencing, which is a form of dynamic. You can convert one to the other. So you can convert dynamic to fixed, fixed to dynamic. It's an offline operation. It's not something you're going to do online, but you can do that. Within the VHD, you'd then partition it. You can also control within the OS whether it's a dynamic disk in the OS or a basic disk in the OS. What you can expand the VHD, whether or not the underlying VM's operating system will then allow you to extend the partitions is dependent on that operating system. So hopefully that will clarify that point.
Sounds great.
I think we're kind of crossing terms a little bit there, where you've got the VHD format, but then that's like plugging a physical drive into a server. The OS then has to see it, and the OS will have constraints over what it can do based on, is it a member of an array? Is it just a standalone disk? Is it basic? Is it dynamic? Is it GPT-based disk? Is it a master boot record-based disk? Those sort of things will then govern, what you can do. I've seen cases where I can expand the VHD, but within Windows it goes, you can't expand the partition.
Oh, we're going to definitely be talking more about that in the next module as well on Hyper-V.
Absolutely.
So let's jump back and talk more about high availability terminology.
Okay.
So what are the basic things of high availability? Well, Microsoft's product is failover clustering. Windows Server failover clustering, it ships as part of the basic Windows Server SKU. Except in Standard Edition, you need to get either the Enterprise or the Data Center Edition. But that's equivalent to VMware HA.
Yep.
Basically, it's our underlying platform for high availability. You can move VMs around to different nodes, or a file server, a SQL server, pretty much any other workload.
Here's an interesting one. Where'd it go? Can you do P2V? So how would you do P2V for a VMware machine? There's a lot of tools out there, both Microsoft and non-Microsoft, that will convert VMDK formats to VHD format. Within VMM, there's a V2V conversion as well as a P2V conversion. The V2V conversion, and I mentioned this particular person that they didn't have much luck with it, couldn't necessarily say why, but that does work and work quite well, where you can actually convert VMDK to VHD, do a virtual to virtual conversion.
Okay, cool. Well, back to the high availability. So one of the key features that we came out with, that Microsoft came out with Windows Server 2008 R2, was live migration, which is equivalent to a vMotion. It allows you to move a running virtual machine from one physical server to another physical server with no downtime by copying the memory. And we're going to get into more details of exactly how that works in the high availability module later today. The next term we have is our coordinator node. Essentially, the coordinator node is the node in the cluster that handles and controls all of the traffic that goes to a disk when you have a distributed file system. Now, the distributed file system that you see with VMware is VMFS, Microsoft equivalent cluster volumes, or CSV. And technically, neither of them are clustered file systems because neither of them have a distributed lock manager. But if you go kind of marketing terms, both of them could be called on technical equivalents as clustered file systems, meaning that all nodes can go and access the disk simultaneously.
Now, I want to tackle this later, but clustered file systems, that's an interesting term. And it's one that we need to dive into because technically neither VMFS or CSV is a clustered file system, right?
Correct. Neither have a distributed lock manager,
so
by industry terms.
Yeah, so let's tackle that later on. They both solve the goal that they're designed to solve perfectly well, but we just want to make sure that there's not, there's a perception a lot of times with CSV, people assume it's a clustered file system,
right?
Because it kind of looks like one to the uninitiated. So, but we've got a whole module on high availability, so we'll.
Absolutely. And the final one we're going to point out is VM affinity. How do you bind a VM to a specific node? And that's an equivalent term we have between VMware. But I did get a question up here. What about VMFT, VMware fault tolerance? Microsoft does not have an inbox solution, but we have partnerships with third-party companies such as Marathon Technologies that allow you to have this kind of fault tolerance system where you can have one VM moving in lockstep and a second one goes into lockstep. Certainly a lot of limitations with that, but again, let's dive into that in Module 4 when we talk about clustering. So if you want to learn more about the fault tolerance, please ask again in Module 4.
Yeah, I think this is the idea of mirroring a VM across two nodes, right?
It is, right? Something happens here, the operation happens here, it gets committed, the transaction sent back, gets committed on the original.
So like if the first one blue screened?
Well, in that case, the second one's going to blue screen. The problem that we have with fault tolerance is it really only works for redundant hardware faults, right? Ability system anyway, you're going to have redundancy in your NICs. You're probably going to have redundancy in doors through multiple. So really, it's only useful if you have something that you can't already have redundant. So maybe full mother. So there's definitely a lot of limitations, and really you're only going to run your absolute most critical systems on something with that, just because it has extensive hardware requirements. It's expensive. You know, it kind of eliminates a lot of the virtualization gains of consolidation. Yet at the same time, a lot of the solutions that are out there on the market today, they limit it to one virtual CPU.
Yep.
So what mission critical systems really only run on one vCPU? Kind of tough, right?
The going back to architecture, the Active Directory guys learned a really important lesson a number of years ago. And this, when I say the Active Directory, I mean like the public that deploys Active Directory. That you can have things so they're too synchronized. You know,
too synchronized.
Yeah, if you get to the point where literally whatever happens here instantaneously, you can start to run into problems where unintended results happen. Like the blue screen. If blue screens, maybe you don't want that
second one's a blue screen, right?
At the same time. And so the Active Directory, one of the design philosophies that is kind of out there now is the idea of a latent site. So you have a couple of domain controllers in a site that is purposely out of sync all the time, and it takes a day to replicate there versus everything else is 5 or 6 minutes. In the event that they have corruption running within in Active Directory, they can go quickly to that site, bump up the I forget the Active Directory term, bump up the version number on the objects, and have it fix the problem. So when you think about high availability, there's a big philosophical debate that you want to have around what the architecture is going to be, certainly in considering all these things.
Absolutely. So let's briefly talk about the Hyper-V editions. So down the line, I guess kind of the interesting thing to talk about is we have the Standard Edition, the Enterprise Edition, Data Center Edition, but then on the far right we have Microsoft Hyper-V Server. How's that different?
It's free.
That's cool. It's completely free.
It's the free edition.
You can actually just download it.
You could just go download it right now. Go go out and Bing Hyper-V Server R2, and you can go download it, and it's free. And it's a brilliant implementation because. So
let's compare it to the Data Center Edition. Well, I'm just looking down the line here.
That's kind of the point I'm trying to make, right? It's identical. You don't lose anything in terms of capability between the free version and the most expensive version. So
what's the big difference then?
Well,
why do we have one free, one that's?
It's an interesting debate that a lot of people have, and I don't know that we necessarily have time for that right now, because I think we need to take a break here shortly. But we'll certainly, I think, ought to come back to that point. But as a bit of a preview, the free edition doesn't have a GUI on it, right? It's based on server core. The Data Center Edition, you get a choice. You can either put it on server core or you can put it on the full edition. And so now it comes down to, well, do I need the Windows Explorer full edition and all the related features that go into that? If it's a virtualization host, you're not putting anything in the parent partition, except maybe you need to configure a driver that can't be done from a command line. So there's trade-offs you would make, and there are legitimate reasons you would go either way. But certainly for VDI implementations, I encourage people to do the free one across the board because it's free.
That's cool. I mean, really for me, I guess the big difference is the licensing, right? You buy the host and you get the host for free, but what about licenses inside the actual VMs? And with the free Hyper-V edition, you don't get any of those licenses.
Which is why it's cool for VDI, because the licenses you do get are for servers, not desktops.
Perfect, exactly. And if you go and buy Data Center Edition, you get unlimited licenses for all of the VMs of Data Center running inside the guest. If you buy Enterprise Edition, you get that host license, 4 licenses running inside the guest. And with Standard Edition, that host and 1 license inside.
But they're not Windows 7 licenses.
That's right.
So VDI, they don't really help you that much.
There are a lot of studies out there that compare these platforms. Now, we're not going to go what's better. We have bias, we say that. But we encourage these independent studies. Project Virtual Reality Check, that goes and does baseline checks against Citrix, VMware, Microsoft, and it finds that they're actually pretty equivalent across the board. In some cases with hyper-threading turned on or off, Hyper-V is better. In some cases, VMware's better. Go and look at the study yourself. Go look at the data and, really make your own conclusion based on that. We're not here to say that one's better than the other. I'm a Microsoft shareholder, full disclosure, so I have a preference. But go check out these independent studies and really try to, understand for yourself what's the best Hyper-V out there. Now, when Hyper-V first, there's some complaints about performance. People saying that, hey, it just didn't work that well. It just wasn't that fast. There were big performance hits compared to running within the virtual guest versus on bare metal. So the Enterprise Strategy Group, they went and they did a really good study. Now, full disclosure again, it was sponsored by Microsoft, but nevertheless, this was run completely independently by the third-party company. And they found that performance really isn't an issue. When we looked at the virtual disk compared to the actual physical disk, it was 4% performance hit maybe. Once we actually looked at the overall workload performance, it was maybe a 10% hit at most. And so when you're really looking at, moving to a virtualized environment versus a physical environment, these concerns about performance really, they shouldn't be there anymore. But go check out the studies, don't take my word for it. Go check it out. Now again, this presentation, this course, it's about the technology, not the sales. But if you do need those sales resources, you need those marketing resources, you have to go convince your peers, convince your boss that this is the best solution. We do have a lot of resources out there, so just go check them out in your own time. I mean, with that, I guess really the key thing we want to highlight here is that at the feature level, Microsoft solutions, VMware solutions, they're pretty much equal now. We have the same technologies. They're implemented differently, admittedly. How they work, it's different. But at least on the feature level, the scenarios that you can achieve, the end goals, from deployment to management to provisioning, we both have it all. So what does it come down to? I mean, does it come down to preference? Does it come down to cost? I mean, when we start to look at cost, generally the studies indicate Microsoft's cheaper. We now have the same feature set. We manage everything. We have great integration stores. It could be a good time to look at Microsoft.
I would be careful in saying that the feature sets are identical. They're comparable. They're not identical.
Comparable. Good point.
And in terms of why someone would choose one versus the other, I don't think either you or I can fundamentally answer that. I think the folks that would do the testing, would do the evaluation, can answer that for themselves. And we can only hope that they wouldn't necessarily go in the direction we would want them to go in. But you've got to do the testing, you've got to do the evaluation in order to kind of answer that question for yourself. But certainly the feature sets and the capabilities and the resources, and when you look at the big picture, they make a very compelling case, to sit down and do that level of testing, do that level of analysis, and do that level of comparison so that you're making the right decision. You're not just basing it on what you would have historically done.
Absolutely.
So I think we're probably set to take a little break here for a minute.
We'll be back in 10 minutes.
Yeah, about 10 minutes. So we will. I usually say I'll see you guys back in 10 minutes, but I can't see you guys, so we'll be back in 10 minutes.